Hello everybody, day 2 of polar equations coming your way now. So today's going to be all about converting equations instead of ordered pairs. We're not going to really look at the graphs too much, we'll talk about them, but we're not actually going to graph anything. We're only going to convert between the two forms. So let's get right to it here. So polar form, just to remind you, is going to have r and theta in the equation. Rectangular form will have x and y in the equation. Starting with this first one here, we want to convert these into rectangular form. So a strategy you can use here, because you want to make it so that we can use those formulas from last class, the x squared plus y squared equals r squared, even though it might not come up with this problem set, tan theta equals y over x equals r cosine theta, and y equals r sine theta at some point. So in order to make it look like these, we would need to have r be squared, and we'd also need to have an r before the sign. The way to do that is by multiplying both sides by r. So that becomes r squared equals 8r sine theta. R squared is x squared plus y squared, so that makes it into rectangular form on the left-hand side. R sine theta is equal to y. So this becomes 8y. Now this problem, to put it in the proper form, it's going to be a circle. So if we kind of put the values next to each other, x squared plus y squared minus 8y equals 0 now. This is going to be a completing the square situation. So to complete the square, just to remind you, we do b over 2 squared. So 8 over 2 is 4, 4 squared is 16. So I'm going to add 16 to both sides. And that makes it x squared plus, and then this factors to be negative 4, y minus 4 squared equals 16. That problem is done. Okay, moving on to this one now. So for this one, it's going to be a little bit different because you see secant is the reciprocal identity, which is different than the sine in the prior problem. So I'm just going to rewrite it as 8 over cosine theta, because secant can be written as cosine in the denominator. Then I'm going to multiply the cosine theta over, so I get r cosine theta equals 8. R cosine theta is something, it's x. So we end up with x equals 8 as the final equation. So it would just be a vertical line there. Okay, moving on to this one now. Very similar kind of problem up here, except there's a little extra trig function in there. Going to multiply everything by r. So I get r squared equals 4r cosine theta plus 6r sine theta. R cosine theta is going to be x, r sine theta is going to be y, and r squared is going to be x squared plus y squared. So converting all those, x squared plus y squared equals 4 times x plus 6 times y. I'm going to move them over to the other side and put them with like terms, so x squared minus 4x, and leave that blank to complete the square, plus y squared plus 6y, leave that blank to complete the square, equals 0. So what would I add here? Well, b over 2 squared here would be 2 squared, so that's plus 4. This would be 3 squared, so that would be plus 9. So that means I need to add 13 to this side to balance the equation. And I end up with x minus 2 squared plus, in parentheses, y plus, it's supposed to be a minus there, minus 3 squared equals 13. So another circle. Over here, I am going to rewrite it as r divided by cosine theta equals 4. Multiply both sides by cosine theta, so I get 4 cosine theta. And what this ends up doing, it just brings us back to where we kind of were over here. So I'm going to multiply both sides by r now. R squared equals 4r cosine theta. And then convert it into rectangular. X squared plus y squared equals 4r cosine theta is x. So we've got x squared minus 4x leave a blank there, plus y squared equals 0. That blank, b over 2 squared, is plus 4 plus 4. So I have x minus 2 squared plus y squared equals 4. So this would be a circle. Even though we're not going to be graphing, it is kind of interesting to think about how these were all circles. So if you think about what the equation looked like in polar form, these polar equations would make circles if you plotted a bunch of ordered pairs. Okay, let's move on to the next set of class examples. We're going to go in the opposite direction this time. So now we're given x and y, and we want to make it look like r and theta. So y equals 5. Well, y equals r sine theta, so we'll just jump right into that. R sine theta equals 5, just replace y with that. These are finished when r is isolated, so I'm going to divide both sides by sine theta. 5 divided by sine theta. And just to make it without a fraction, I can rewrite this as r equals 5 cosecant theta, which is sine theta written on the top as cosecant theta. Over here, everywhere I see an x, I'm going to put r cosine theta, so 3r cosine theta minus 2r sine theta for the y equals 4. I am now going to factor out an r. And I'm going to divide by that whole thing. This time, because that denominator is a little bit more complicated, it is not easy to get that out of the denominator, so I'm just going to leave it just like that. Okay, now moving on to some circles. X squared plus y minus 1 squared equals 1. I'm actually going to FOIL that parenthesis out there. So y minus 1 squared means y minus 1 times y minus 1. That becomes y squared minus 2y plus 1 equals 1. If I subtract 1 from both sides, that cancels it out. And then over here, I have x squared plus y squared. X squared plus y squared is r squared. So we get r squared there, minus 2. But instead of y, I am going to put r sine theta. And because the 1's canceled out, it just equals 0 like this. I'm going to add 2r sine theta to both sides. And finally, divide both sides by r to get 2 sine theta. So it's kind of like this one up here, r equals 8 sine theta, just going in reverse. Okay, moving on over here. So we have x minus 2 squared plus y plus 4 squared equals 20. Let's FOIL everything. X minus 2 squared is x squared minus 4x plus 4. And this is y squared plus 8y plus 16 equals 20. By no coincidence, when we subtract 4 and 16 to both sides, it ends up canceling out that side. That's just the way these are going to work. Regrouping these to make them easier to convert, I'm going to get x squared plus y squared equals, or minus 4x plus 8y is equal to 0. X squared plus y squared, that is r squared again. So I get r squared equals, minus 4 r cosine theta plus 8 r sine theta, using these two equations here, converting the x and y's into their proper forms. Now I'm going to move everything except the r squared over to the other side, so I get r squared equals 4r cosine theta minus 8r sine theta. Divide everything by r, and I get r equals 4 cosine theta minus 8 sine theta. And there we are. The problems in the textbook that I want you to do are very similar to this. So, good luck.